Have you ever seen something like that, guys? I don't. Hey guys, Lucas here and welcome at Case New Space. Today another video about coding in KSP. In the last video we were working on a flight computer to make this little rocket here hover. Let me test it. As you can see, instead of throttling the engine smoothly, we kind of make it pulse. And this pulsation made me curious. Can I create a flight computer that can control the throttling by pulsating it? Well, we can just test it out. Now, because for Kerbal safety is on the top of the list, I have developed this rig here, and not a rocket. This rig will hopefully not go anywhere. And of course, our safety officer is on board as well. Hello, Bob. So instead of throttling up gradually, I will toggle the engine on and off, like so. And by increasing the thrust, I want to increase the rate. I hope you get the idea. This concept was of course made popular by NASA and their project Orion. However, they didn't use regular engines but nukes. We don't need nukes though. What we are using is a so-called pulsating detonation engine. Of course, only simulated in KSP. The main advantage of a traditional engine is we can use higher temperatures. And by pulsating it, this higher temperature won't melt our combustion chamber. That's at least the theory. But what we are here for is just the control. We begin using this boilerplate code we have developed in the previous episode. All it basically does is to create a nice console application, which looks like this. Right now it's just a timer, of course. Let's go out of here. I think there are two main approaches to solve this problem. First, we could pulse the engine and then reduce the max pulse throttle, so to speak, in order to reduce the thrust. However, I think that's unrealistic because with a normal pulsating engine, we want the pulses to be as strong as possible for max efficiency. So what we are going to do instead is to vary how often we pulse, basically like this. Low throttle and then slowly increasing it. Until we reach a max value of 50-50, basically pulsating as often as we're not. It's basically like a clock, tick-tock. So the first thing we will need is our own throttle. And to make that more clear, I will print out both the KSP throttle and our own throttle on the screen. Simply copy and paste this here. I'm by the way using a new editor, so I have to get used to that one as well. Copy. Like so. KSP throttle, and that was of course our controller dot throttle, and our own throttle doesn't exist yet. And I will simply call that throttle. Okay, let's put that up top here. Let's give it some default value of 0 and save. Okay, now we want to track new buttons to control the throttle. And for that I will simply use 1 and 2. 1 to increase it, 2 to decrease it. So else if key pressed, 1 and 2. If we press 1, I want to increase throttle by, let's say, 2.25. And decrease it using 2. So now we will run into the same problem we had last time. If I press the button too long, it will do multiple iterations of this loop. So I could put a sleep timer in here. However, if we sleep here, we will completely mix up our pulsating, because our pulsating will depend upon this loop's iterations. So in essence, we can't sleep. We have to use another trick. And the trick is quite simple. We will use a counter. So once this button is pressed, we will increase a counter, and this counter will then count down, let's say 5 times, until we can press this button again. So if we press this key and our counter is equal to 0, only then we will be able to change our throttle. And in here we will increase our counter to, let's say, 5. And of course we have to initialize it on the top here, and do the same for the other button. Now, of course, in the main loop, we have to make sure the counter actually counts down. Minus equals 1. Just in case you don't understand this line, this basically means our new counter is the old counter minus 1. So this is just for short. But it's the same. I've used that a couple times already, so maybe it confused someone. So again, we want to press a button to change our throttle, but we don't want to accidentally change it more often than we need to. So every time we increase or decrease our throttle, we will wait for 5 cycles before we can press the button again, without slowing down our loop, which is important for our pulsating engine. I hope that is clear. Now let me test it. Saved. Oops. I again forgot to increase my cursor movement by 2 this time. And again. Okay, we have the KSP main throttle. And by pressing 1 and 2, nothing happens. Where is the issue? First, let me remove the units, because it's of course not seconds. We want to show it in percent, and for that we still miss times hundreds. And we don't want any decimal places, so 0 floating points. Okay, but that was not the issue. The issue is, I don't know yet, but there is a trick to simply print test on screen in order to figure out if our button presses are actually recognized. So let's test it again. Nope, I'm pressing 1 and nothing happens. So the issue must have to do with recognizing if the button is pressed at all. Ah, of course, I see the issue. We initiate our counter with 0, and while we didn't press any button, we still decreased its value by -1, so it never got to be 0 to begin with. So what we have to do, we have to protect the counter from going below 0. So if counter is bigger than 0, count it down. Otherwise, it will remain 0. Okay, that should have done it. Let's test again. So we have our KSP main throttle. That works. And pressing 1 also works. However, we can still go beyond 100, and I think we can still go beyond 0. So we have to fix that as well. And that is simply solved with a if statement in here. If throttle is smaller or 0.75, do this. And here, if it is bigger or equal to 0.25. Let's test again. Oops. I forgot double points. Happens all the time, by the way. Okay, here we go again. Normal throttle works. Okay, we can't go beyond 100 and we can't go below 0. That's all there is to it. So what we now need is a function to pulsate the engine using our throttle. I call it pulse engine. And of course we have to create it. Now, important to note, this function will run once every loop. So we have to switch our throttle once every loop as well. Define pulse engine. And of course we also need the main real throttle. So we will hand over the controller as well. So in here we will set the main throttle to 1 or to 0. Now we just have to think of some logic which will make that happen. One way to do this is to have another such counter, but this time we only need to count from 0 to 1, like tick-tock. So in essence, if tick equals 1, if tick equals 1, we want to throttle up, and else we want to throttle down. Now, of course, we again have to hand over this value like so, create it up here. So let's begin with 0. Now the first time this function runs, we will not throttle, we will stay at 0. So in here we have to say tick equals 1 to change it to 1, such that with the next iteration it will throttle up. And in here we have to change it back to 0, so that on the third run it goes back to 0. I hope that makes sense as well. So let's just try that. Main throttle. Okay, our throttle can't do anything yet because we haven't really defined it yet. But we should still throttle up, I think. Okay, let me check that again. We come in here. Ah, yeah. So this is now a so-called Python quirk. Because we hand over a value. Tick is a value. So the tick inside our function is not the same as the tick outside of it. So by changing tick in here, we don't change it outside the function. Now you might wonder, but wait a second, why does it work for throttle? Well, because we don't hand over the throttle itself, we hand over an object controller which handles the throttle. So the controller in here is not the controller outside of the function, but the throttle it controls is. Now this can be a bit confusing, so let me just fix it and you'll see how it works. So instead of creating a tick value, we create an object, and an object is created using the keyword class. And let's just call it a clock, why not? And this class clock controls the tick. And instead of handing over the tick, we hand over the clock. Like so. And in here we have to use clock.tick now. Clock.tick. Okay. So clock is an object which controls the tick. We make a copy or hand over the object, and this object from inside the function controls the tick outside of it. At least in theory, but it should work, I think. Let's try it. Oh yeah. I think Bob is happy. Oh, let me turn that off. Okay, that was quite loud. So that works now. And while we have this object clock, why not also put our throttle, our new throttle, into it? Just to clean up our code a bit. So in here, okay, we're not using that throttle yet, so nothing to change in here. Now comes the tricky part, guys. We have to somehow make this function tick differently based on the throttle setting. So in essence, with a throttle of 1, we want to tick tock 50-50, so to speak. Now with throttle at 0.5, we want to tick half as much. So the half of 1/2 is 1/4. Tick, tock, tock, tock. Then tick, tock, tock, tock again. And the same for our throttle at 0.25. This time we need 8 ticks or 8 tocks. Tick, tock, 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 tock. And to keep the same length, I will also extend this one here. Tick, tock, tock, tock. Tick, tock, tick, tock. And let's do one more in here. Throttle at 0.75. Will be something in between this and that. Let's just make something up. Tick, tock, tock, tick, tock, tock, tick, tock. It should fit. Not perfect, but that should do it. So it will now tick, tock, tock, tick, tock, tock, tick, tock, tick. But okay. Now how do we represent this as something the code can understand? Well, for that there exist arrays. So let me call this array a pattern. And this pattern can, for example, consist of ones and zeros. 1 for tick, 0 for tock. So let's represent the first one. Tick, tock, 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 tock. Is that enough? Yes. So this is pattern 1, so to speak. Pattern 2.
I hope you get the idea already. Pattern 3, the same. And the last one for full throttle.
Oh, we had a mistake in here, a typo. This looks good. So now all we need is to choose this pattern. If the throttle is at 0.25, choose this one at 0.5, choose this one at 0.75, and this one at full throttle. So let's just do it. If clock.throttle equals 0.25. Now, of course, we don't need the numbers here because we just change one and the same pattern into something else. Oh, so we also have to initialize it before. I'll just choose an empty array. Oh, wait. We can use this initialization to configure our zero throttle. Okay, so that's the default value, is 0. I hope you can follow, guys. It's really not that complicated, I hope. But you never know. Okay, so if clock throttle equals 0.25, we use this pattern, then this. That should do it. So now instead of using this tick here, which just switches from 1 to 0 every loop, we want to use this here, 10000, 10001, and so on. How do we do that? Well, we can access a position of an array one by one, and that is done by pattern square brackets, and now a number between 0 and 7. So it starts at 0 and ends at position 7. So our tick has to tick from 0 to 7, not from 0 to 1. Clock.tick. So if we for a second imagine that this clock.tick ticks from 0 to 7, we will jump from this position to this, one by one, and every time it is 1, it will throttle up, and every time it is 0 it will throttle down. Now of course in here we have to increment our tick by 1, in here 2, and every time the tick reaches 7 we want to default back to 0. So if clock.tick is bigger or equal to 7, after it went through this we want to change it back to 0. Like we did before, I think, right? Yes, like we did with the counter here. It's practically the same. Okay, let's just think this through again. We create a pattern for our 0 throttle. If the throttle is not 0 but 25, we use this instead, or this or that. And then we check each position of the pattern using the clock's tick. And if it happens to be 1, we throttle up, otherwise we throttle down. We increment the tick every time. Wait, now because we do this every time, we don't have to do it inside this if statement. We can simply do it on the bottom here. Like so. I think we have to do this after. Yes. So if the clock is 7 already, we set it to 0. If it's not 7 yet, we increment it. I think the other version we had was wrong actually. Because if it had been 0, it would have incremented to 8. Yeah, but okay, it would have still changed to 0 here, so no problem. Anyways, let's try it. Oh, surprise, we have an issue. If clock.throttle okay. We use just a simple equal sign, which is of course not a comparison. We have to use double equal signs here. This is for comparison, and the single equal sign is for assigning a value. And we of course don't assign throttle something here, we check if it is 1 or not. Okay, this should have fixed it. Ooh, that works. Okay, our regular throttle. Oh, as you can see, we cannot throttle up with the regular throttle anymore because it will of course be set to 0 in our pulse engine loop. Now let's throttle up. We should see something happening now. Why don't we? Wait. Clock.throttle. Oh wait, what's that? We forgot to throttle up our clock.throttle. We didn't change it in here. Yeah, we can remove this line here too, because we use it in here now. Okay. Now let's try it again. Throttle up. What's this again? If throttle, name throttle is not defined. Okay. Where? Here. That's how bug fixing works, guys. It's a little bit exhausting sometimes, but as long as we get to the finish line, we profit. And now, hopefully, the final time. Oh yeah. 50%. Isn't that beautiful? I think this makes Bob really happy. Now it's time to use this on a real rocket, I think. Let's go. Okay guys, this is what I've cooked up. I call it the Orion. Let's start our computer. And thrust. Holy moly. What have we created, guys? Now we can change the damping here, the force. In order to use as much of our dampers as possible. Holy moly. I think it's a monster. And let's go, guys. Launch. Oh my god. It actually flies. And quite well, if I can say so myself. Oh, 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 oh. No. Throttle back up. Wow. This feels so crazy, guys. I think the issue here is the thrust vector control. Because it is mounted to these poles, it goes bananas really fast. Let's fast forward to space a little. Have you ever seen something like that, guys? I don't. I also have an idea for the next episode. Instead of controlling this rocket using the thrust vector control, we could use differential thrust, meaning in order to pitch down, we could throttle this engine more than this. The same for your controls. Throttling this more than this would turn us to the left. Yeah, that's what I'm going to do the next episode, guys. Until then, auf Wiedersehen and thank you for watching.